In this lesson, we'll do another example problem involving one-sided limits. So here again, we have the graph of a function y equals f of x, and to start, we're asked to compute the limit as x goes to -1 from the right of f of x. So we find x equals -1, and we want to find the values of f of x as x comes into -1 from the right. So we see that our function f of x, the values are getting closer and closer to 2 as x comes into -1 from the right. So our right-hand limit is equal to 2. Next, as we come into -1 from the left, so the values of x are less than -1, here we see that the values of our function are getting closer and closer to 1 as x comes into -1 from the left. So this means that our overall limit, the limit as x goes to -1, does not exist because the two one-sided limits are not equal to one another. The right-hand limit is equal to 2 and the left-hand limit is equal to 1, so the overall limit does not exist. And finally, what is the value of f of -1? So this is the value of f of x when x is -1. This closed circle at 2 tells us that the value f of -1 is equal to 2. So next for this example, we're asked to explore the behavior around 0. As x comes into 0 from the right, so the value of f of x is getting closer and closer to 2, so the right-hand limit is equal to 2. As x comes into 0 from the left, again we see that the values are getting closer and closer to 2. The two one-sided limits are equal to one another and are equal to 2, which tells us that our overall limit x goes to 0 f of x is equal to 2. And finally here, f of 0, we don't have any holes or jumps to worry about, so f of 0, the value of f of x when x is equal to 0, is equal to 2. So here, all of the one-sided limits, the limit as x goes to 0 and f of 0, were all equal to 2. Next, with this example, we're asked to explore behavior around 1 and 2. So we'll start with the limit as x goes to 1 from the right. Coming into 1 from the right, values of x that are greater than 1, we see that our values are getting closer and closer to 2. Again, we don't need to worry about this open circle because we're just worried about the values as x gets closer and closer to 1. Coming into 1 from the left, again, the values are getting closer and closer to 2, which means so the left and the right-hand limits are both equal to 2, which means that our overall limit x goes to 1 of f of x is equal to 2. So the limit as x goes to 1 of f of x is equal to 2. Now what is f of 1? This is the value of f of x when x is equal to 1, and this closed circle here tells us that f of 1 is equal to 3. So here the two one-sided limits and the overall limit were equal to 2, whereas the value of the function f of 1 is equal to 3. And now finally for this problem, we're just asked to find the limit as x goes to 2 from the left of f of x. So coming into 2 from the left, values of x that are less than 2, and we see that this limit here is equal to 3. So the key ideas to remember when you're working with one-sided limits are that you're not interested in the actual value of the function, you're simply looking at what happens to the values of the function as x comes into your number c from the left and from the right.